What's up, guys? We're going to talk about how to use a protractor. We have two different types of protractors in our classroom, and I'm going to use both of them to show you how to measure angles of this triangle for this triangle investigation. Alright, so let's start with the Office Depot protractor. And we got some important things to talk about here on this Office Depot protractor. We got this line here in the middle. We've got a 0 on the right and a 0 on the left. You can use either one of those. If you use the 0 on the right as the bottom of the angle that you're measuring, then you're starting on the inside track here, using those numbers. If you're using the 0 on the outside on the left, guess what? You're going to use the outside numbers. Okay? And this center point lines up with the center point of your angle. So let's use the Office Depot protractor to measure this first angle. I'm going to stick this center line right on the vertex. Ooh, yeah. We're going to have to do a little slidey of the paper. Cool. So the center line is matched up with the vertex, and the 0 is matched up with the bottom of this angle that we're trying to measure, this big angle. Cool. Vertex in the center, 0 matched up with the bottom. Vertex in the center, 0 matched up with the bottom. Well, I'm using the 0 on the inside, so I'm going to track over on the inside numbers until I see where my other line goes through the protractor. Well, it doesn't. So what I can do is extend that line. Let's extend it with a fat marker. Okay, watch out. I'm going to move this and then use the straight part of this straight edge to extend my line. Oh God! Oh no! That should be long enough. Cool. Okay, let's bring it back. Vertex is in the center. 0's matched up on the bottom. I'm on the inside. Okay, looks like it goes through right between 110 and 120. Right between that would be 115 degrees. So this angle right here is 115 degrees. Hot dog! Alright. So let's use the other protractor to measure another angle on this sucker. This one's a little different. It's got a center circle instead of a center line, but it still has our 0s here on the bottom, but you'll notice it just has a 0 on one side. Oh, okay. So what that means actually is if we look at these numbers on the inside, 50, 40, 30, 20, 10, there's that number here. This line here is also a 0. So we still have 0 on the outside. Let's use the outside numbers. 0 on the inside, also known as this bottom line. Let's use the inside numbers. Okay. So let's measure the tiny angle, shall we? I flip my paper around because I think that makes it easier. This circle is going to go on the vertex. This bottom line is going to match up with the bottom line of the angle that I'm trying to measure. Okay, we're measuring this angle here. Alright. Kind of in the shot, that's good. Circle on the vertex. Well, this is a little... These lines are super fat, so there's some room for error there, which is okay. Circles on the vertex. Bottom line is matched up with the bottom line of the angle. So I'm using the 0 on the inside, so I'm looking at my inside numbers to see where this line crosses the protractor. Looks like it's between 20 and 30, right between 20 and 30. So I'm going to call that 25 degrees. This is 25 degrees. Now, if you're clever, you can use your interior angle sum theorem to figure out that third one without measuring at all. Booyah, Grandma. Nicely done. Have a good time.